Hi guys, and in this video we're going to look at the Unit 4 Independent Task 5. So the same with the other ones, we removed the topic names for this for these tasks, so you need to practice that skill of identifying what the question is so you can apply the correct skill. So these are the topics we had. Number 1 was a uniform distribution. Number 2 was hypothesis testing with a normal distribution. Probability, moments, and then forces of friction at angles. Okay, so you should have completed these questions, and you should have got to a certain level of support. So remember, if you're using no level, so you're not using any of the levels, then that's a topic that you know well, and that you just need to keep ticking away in the background. If you get level 1 or level 2, that's a topic that requires a small amount of action, and then level 3 and level 4 is a topic that requires a lot of action and needed a lot of work. Okay, so question 1, we had a uniform distribution. A gardener has a piece of wire, a wire cutters, and a piece of wire that's 150 centimeters. So there's my wire, it's 150 centimeters long, with a ring attached to one end. So see the ring's over here. The gardener cuts the wire at a randomly chosen point into 2 pieces. So I cut anywhere. I can cut it at the ring, I can cut it in the middle, maybe towards the other side. I can cut it wherever I want. The length of the piece of the wire with the ring on it represents a random variable x. So straight away, I know x, and I've got uniform distribution here because I can cut it anywhere, and it's going to range between 2 values. Okay, and it's obviously continuous because it can be decimals or anything like that. Now, the length with the ring can be, the biggest it can be is 150. I can cut it right at this bottom end, and that means it's 150. So I can go up to 150. The smallest it could be is if I cut it at the ring end, which would be at 0. So it's going to range anywhere between 0 and 150. So if I want E of x, this is the formulas in our booklet. Okay, so A plus B, so 0 plus 150 all over 2, and I'm going to work that out. That's 75. So that's my E of x. For part B, I want the standard deviation. Now to do that, I need to find the variance first. Okay, so the variance is B minus A squared all over 12. Okay, and if I work that out, I get 1,875. And that's my variance. My standard deviation is simply going to be the root of that, which comes out as 43.3. That's my final answer. Now, part C is a little bit weird. Now, you'll notice we're 3 marks in, so you've got to be a fair amount of work. Now, something I didn't do up here is I should have drawn out my distribution. Okay, so I've got to go between 0 and 150, so my height must be 1 over 150 because B minus A. Okay, so I'm going to use that to help me here. The probability that the shorter piece, so it's not talking about the wired piece, it's talking about the shorter piece, is at most 30 centimeters long. So there's actually 2 scenarios here, okay? I either cut it here, and this length is at most 30 centimeters, or I cut it down here, and this length is at most 30 centimeters. Okay, now the first one's very straightforward, because that's my ring size. So this first section by here is going to be the probability that x is less than 30. Okay, the other scenario is this top end being 30, so this distance here must be 120 or bigger, because I want to be less than 30 on this side. So I'm also going to do the probability that x is greater than 120. And I'll work them both out separately. So my height is 1 over 150. My base is going to be, if I want less than 30, that's going to be from 0 to 30, so times by 30. So 30 minus 0 if I'm thinking about the base length. And then this one's 1 over 150, and then I'm going to do 150 minus 120, because that would be the top end. Okay, again, if I'm looking at my graph, 30 would be about here. I'm looking for that area. And then 120 would be about here. I'm looking for this area. Okay, I'm going to time them together and add them. Gives me 60 over 150, or a simplified version of that as well. So for number 2, we have our hypothesis testing. Okay, now quite a big question here. It's 6 marks. So we've got a lifetime of a new 60-watt energy bulb. It's modeled as a normal random variable with a standard deviation of 640. So that's my first bit. That's my my sigma. A random sample of 25. So that's my n. Is taken, and the manufacturer and the mean life is found to be this. This is my observed, or my x bar. Okay, I want a 1% significance level to see whether it's changed from 20,000. So that's my current mu. So my first thing is going to be let x, and then we're talking about the lifetime of a new 16 watt light bulb. Okay, so the current distribution, not x bar, the current distribution is it's normally distributed. It's 20,000 what's currently in place is my mu, and then my sigma was 640 squared. Okay, and my next thing is I'm going to set up my H0 and my H1. Okay, mu is currently 20,000. I want to see if it's changed from that. So because it's not greater than or increased or decreased, it's going to be not equals to. Okay, because it could be either. If I'm talking about being changed, it could be bigger than it could be less than it. As long as it's changed, that's what's mattered. Next thing I'm going to do is I'm going to do my sample mean. So n is 25. So my x bar, my mu doesn't change. My standard deviation does. So I get 640 squared all over 25. Okay, and if I'm thinking about what goes in my calculator, I'm going to square root the top and bottom. So that's 640 over 5. Okay, which again I could work out, but I'm just going to type down my calculator. Now from here, there's two methods we can do. We can either do p-value or we can do critical regions. Okay, now I'm going to do critical regions. Okay, this method that I prefer. So the first one is the probability that x bar is less than a. I'm going to half my sig level. So I'm talking about 1%. Okay, so if I half that, because I'm a two-tailed test, I'm looking at 0.5% either side. So 0.005. Okay, I've got my distribution. I'm going to use that to help me find a 19670. Okay, I'm going to do something very similar for the top end. Okay, this one though is going to be 0.995, so one take away it. Okay, so my B comes out as 20330. Okay, so therefore my critical regions have to be x bar being less than or equal to 19670, or x bar being greater than 20330. And I got these values A and B from using my inverse normal on my calculator. Okay, my next step is I'm going to compare the observed value to my critical regions, and I'm going to see does it fit in, which it doesn't. Okay, it's not less than this smaller value, and it's definitely not bigger than the other value. So I'm going to state that quite obviously. Okay, I'm going to say 19700 is greater than. Okay, so not in critical region. Okay, if it's not in your critical region, it is insufficient evidence to reject H0. Okay, and then I need this context. So I'm going to say, so insufficient evidence to suggest the mean lifetime has changed. Okay, I could talk a bit more depth to say that it's a mean lifetime of the 16 watt energy saving light bulb, okay, but that would be enough to get me the mark. Okay, so number 3 then, we have probability. Okay, so it is known that 5% of animals of certain species have a particular disease. I apply a test to see whether or not the disease is whether or not they have the disease. So the first thing, this is kind of leading me to do a bit of a tree diagram. Okay, so the first thing I've got is they either have the disease or they don't have the disease. Okay, so if they have the disease, it's 0.05. If they don't have the disease, it must be 0.95. From there, I apply a test, and I either get a positive or a negative response out. Okay, if I apply to someone who has the disease, it gives a positive of 0.96 at the time. So that means 0.04 of a negative. And then similarly with the other one, if I give it to someone who doesn't have a disease, it gives me 0.02 of a positive, so 0.98 of not having a positive. Okay, so part A, I want to calculate the probability of a positive. Okay, so I'm going to follow my branches. That's they have the disease, 0.05, and I get a positive, or I get the probability they don't have the disease and they give me a positive. Okay, and I'm going to plug down my calculator, 0.067 as my final answer. Part 2, here it is, given that's my conditional formula, so straight away I'm going to set up my given formula. Positive response goes after. Find the probability the animal has the disease. So that's going to probably they both happen. So probably they have the disease and I get a positive, all over the probability I get a positive, which is what I just found. Okay. Most of the time, for that second part, they've made you calculate the denominator in the first part, okay, but that's not always the case, but that's quite often, if you look at past papers, what they do. Okay, so for the next one, we've got a little bit harder, a little bit more to think about here. A randomly chosen animal gave a positive response. So I've already got a positive response from them. It's tested again. Find the probability that it gives a second positive response. Okay, so there's two scenarios here to think about. Okay, either they've got the disease, given they give a response, and they give another one. So I'm going to use what I did before, 0.716. That's probably that they have the disease, given that they've given me a response, a positive, and then I'm going to times that again by 0.96. Okay, that's one response. The other one is going to be the opposite. So they didn't have the disease, so I'm going to do one takeaway. And then they give me another negative. So this is someone who doesn't have the disease, so the probability of them giving me a response is 0.02. Okay, so I've set up my calculation. I'm going to plug it in, and I get that as my answer. So that's part one. It's quite a difficult thing to think about there. The second one is you're given that. So given that they have the disease, probability of disease given second positive. Okay, again, I've got the fact of their second positive here. So that's the 0.716 times 0.96 on the top. That's both of them happening. That's the first section I had by here. And then my 0.693 goes on the bottom. Okay, gives me 0.992 as my final answer. So a little bit of a tricky one there. Okay, but I'm trying to get you to use your previous answers as much as you possibly can, okay? Now, if you did get this one wrong here for part A, part 2, and you use the number here in part B, you will still gain the marks for error carried forward. So it's important that we do carry on and keep thinking of them as we go through. Right, question 4 then, we got moments. So we've got a uniform rod of AB. So straight away, I'm going to draw a nice straight line, AB, and start labeling things. So it's uniform, so its mass, its weight is going to go in the middle. And length of 6 meters, so 6 meters in total, is suspended horizontally in equilibrium by means of 2 vertical strings, so vertical strings at point C and point D. Now they tell me AC, so this length here, is 1.6. Okay, they tell me A to D is 4.8. So I'm gonna use my lengths here. HG should be in the middle. So this should be at 3 meters from here. So this is 1.6. This one would be 1.4. So that's 3 meters. I need another 1.8 to get me over to here. And I'm missing 1.2 over here. So I find it really useful to put all my little lengths on and I can add them up afterwards. Now, because I'm hanging from strings, I should have a tension at C and I should have a tension at D. Okay, so there's all my forces and lengths on. So calculate the tension in the string in C and the tension in D. So the first thing is I'm going to take moments. Now, benefit of taking moments is if I take it about a certain point, I can eliminate the force on that point. So for example, I'm going to take moments about C. What that does, it eliminates this TC. This disappears. Just remember, moment is force times distance. So clockwise, this 8g is going to go clockwise, and it's 1.4 meters away from C. Okay. The other force is TD, and let's go anti-clockwise, and that is 3.2 meters away, because I'm going to add these two lengths together. Okay. Now from there, TD is the only thing I don't know, so I can solve it. I get 34.3 newtons. Okay. Now from here, I've got two choices. Okay, I either take moment again, but I do about D, and I can do the same kind of thing again, or what was a lot easier is me to resolve vertically. Okay, my forces going up should equal my forces going down. So I've got TC plus TD going up, and then I've got HG going down. And I can now solve that for TC because I know what TD is, and I get 44.1 newtons. Okay, now you can kind of see here, it's not a huge amount of work here, and it's worth 7 marks. Okay, so it's because of this initial setup at the top. Okay, understanding what is happening before you get started. That's the difficult bit, because once you get started, you think about taking moments, you think about resolving vertically. Okay, so the final question, we've got a sledge. Okay, there's quite a few things going on with this one. It's a bit different to normal. I've got a sledge of mass 12 kilograms is being pulled up a rough, straight away, I'm thinking about friction, slope incline at 20 degrees. So let me draw that first. Let me draw my very generic block, which is 12 kg. On my slope is 20 degrees. So I've got 12g going there. I've got my normal reaction going this way, okay? Now, it's being pulled by a rope, which is inclined at 10 degrees to the slope. So the rope is also at a slope. Okay, and tells me the tension in the rope is 80. So this angle there is 10. Okay, now, because it's been pulled up the slope, friction must be going down, so F max, and it tells me mu is 0.2. Okay, calculate the frictional force. So for the frictional force, I'm thinking about it, I've got F max is mu r. I know what mu is, I don't know what r is, so I need to calculate that. So to calculate that, I'm going to resolve perpendicular to the slope. Okay, so going up and going down. So going down, I've got my 12g and then cos of 20, because remember, if that's 20, this angle here must be 20. Okay, going up, I've got my r, but I've also got the component of this 80 going up. Okay, so we've got to be careful about this. It's not just working parallel, it's also got that working perpendicular. So I'm going to add to this side 80, and that would be sine of 10. Now, very similar before, I know everything, I know what g is, so I'm going to take this over to the other side, I'm going to solve that for r. Gives me 96.616 newtons. Okay, now I know that, I can go, okay, using F max is mu r, I've got 0.2 times this 96.616, gives me 19.323 newtons is my final answer. Now, a follow-up question to this could have been calculate the acceleration, and I could apply Newton's second law in the parallel direction, and I could see where that would end up. Okay, but be careful, because this rope's also at an angle. I need to consider that when I'm resolving perpendicular. Okay, so apart from that, you should have marked those, and you should have made a note of what level of support you need to do. If there's anything else you need, please let me know. But apart from that, I will see you in the next lot of tasks. So thank you, guys.